from our screen, this is question on motion. Please note that anytime you have questions that regards to motion in physics, you should expect your parameters or your data to be either speed, which is velocity, then distance in meters, then either acceleration, which is also deceleration when it is negative, and then your time. These are very important components when solving questions involving motion. From this question, you see that the boy is moving with a velocity of 3 meters per second. Our initial velocity is 3 meters per second because he is already in motion. Then he was now brought to rest by a constant force. After traveling 15 meters, he covered a distance of 15 meters. We are asked to calculate the retardation. Now, the retardation here is the negative acceleration. And when you find your acceleration, the negative form of your answer automatically becomes your deceleration. So, the formula that can suit our question perfectly will be the third equation of motion, which is v squared is equal to u squared plus 2as. Now you can see the boy walking and is covering the distance. The first arrow is the point of initial velocity, and then the final arrow there is the final velocity, the point at which he was brought to rest. So applying and substituting into v squared is equal to u squared plus 2as, we have 0 squared is equal to 3 squared plus 2 into a into 15, so that you have 0 is equal to 9 plus 30a, and then 0 minus 9 will equal 30a by collecting like terms, so that negative 9 divided by 30 will equal negative a. So that negative 9 divided by 30 is equal to a if you divide through by 30. Hence, negative 9 over 30 will give you negative 0.3 meter per second squared as your deceleration. So if you are asked to convert your deceleration to acceleration, you simply multiply through by negative sign so that you obtain 0.3 meter per second. Hence, it gives you both acceleration and deceleration. Take note of that. The next question here, a car moving with a speed of 90 km per hour. 90 kilometers per hour. Hence, our V is equal to 90 kilometers per hour since speed is mentioned, and speed is the same thing as velocity. And it was brought to rest by the application of brakes in 10 seconds. So our time is 10 seconds. How far did the car travel after the brakes were applied? So if you look at this question, the first arrow is the point of origin and the second arrow is the point of termination. If you watch the car that is moving on your screen. So our V will equal 90 kilometers per hour. But your parameters here is in kilometers per hour. We need to convert to meters per second. Hence, you say 90 multiplied by 1000 meters divided by 60 multiplied by 60. We are converting to seconds. Hence, you say 90,000 divided by 3,600, so that V is equal to 900 divided by 36 by reduction. Or you now say that V is equal to 25 meters per second. Acceleration is not given. Then for us to find our A, which is acceleration, so that we can substitute into a formula, which is distance is equal to ut plus half at squared. A is missing. Hence, A is equal to v over t, which is acceleration is equal to change in velocity divided by time. So you have A is equal to 25 divided by 10, so that you have acceleration to be 2.5 meters per second squared. Our time already is given as 10 seconds. So if we use second equation of motion, S is equal to ut plus half at squared. Distance now is equal to 0 multiplied by 10 plus half multiplied by 2.5 multiplied by 10 squared, so that our distance is equal to 0 plus 1 over 2 times 2.5 times 100, so that our distance is equal to 0 plus 2.5 multiplied by 100 divided by 2, so that you have distance to be 0 plus 250 divided by 2. Then our distance is equal to 125 meters. Your final answer. So this is how far the car traveled after the brakes were applied. The brakes were applied from the first arrow, and then the car was brought to rest at the second arrow. Take note of that. This question states that an aeroplane lands on a runway. You can see from our diagram the plane landing on the runway at a speed of 180 kilometers per hour. So it means our initial velocity is 180 kilometers per hour. Take note of the SI unit, kilometers per hour. We can't use this directly. We need to convert to the standard SI unit of velocity, which is meters per second. So by so doing, we have 180 kilometers divided by 1 hour. So that we can say 180 multiplied by 1000 meters divided by 3600 seconds. 60 multiplied by 60. So that I have 180,000 divided by 3600. So that 1800 divided by 36 will give you 50 meters per second. So our final velocity from the equation it was brought to rest uniformly is 0 meters per second, and then our time is 30 seconds. So we are asked to calculate the distance it covers on the runway before coming to rest. So we can't find distance without acceleration. So acceleration is missing. Hence we can calculate for acceleration by using the first equation of motion based on our parameters. So that V is equal to U plus AT. Hence 0 is equal to 50 plus A into 30. So that 0 is equal to 50 plus 30A. So that 30A is equal to 0 negative 50 by collecting like terms. So that A is equal to dividing through by 30 over 50 divided by negative 30, or negative 50 divided by 30. So that I have A to be negative 1.67 meters per second squared. Now, if we substitute that, since we are looking for distance covered by the plane before coming to rest, the second equation of motion, distance is equal to UT plus half AT squared. So that your distance is equal to 50 into 30 plus 1 over 2 into negative 1.67 from our answer of acceleration into 30 squared. So that distance is equal to 1500 plus 1 over 2 times minus 1.67 times 900, 30 squared. So that S is equal to 1500 plus half multiplied by negative 1503. S is equal to 1500 negative 751.5. Subtracting, our distance will equal 748.5 meters, which is approximately 749 meters or 750 meters to the nearest 10. So that is the distance covered by the plane through the runway before coming to rest, from the first arrow to the second arrow. From this question, it reads that 2 points on a velocity time graph. So velocity will be on the vertical axis and time will be on the horizontal axis. So have a coordinate of 5 seconds, which is our time, 10 meters per second, which is our velocity, and 20 seconds, our time, and 20 meters per second, our velocity. So calculate the mean acceleration between the 2 points. So the mean acceleration from that question will be change in velocity over change in time. So drawing our graph as you are seeing on your screen, velocity, the highest value here is 20 meters per second. We'll connect that to 20 seconds. You can see that. Then the other coordinate is 5 seconds and 10 meters per second, which is velocity 10 and then time 5. So substituting into A is equal to change in V over change in T, you have 20 negative 10, that's change in V, divided by 20 negative 5, change in T, so that A is equal to 10 over 15, so that your acceleration is equal to 0.67 meters per second squared. Take note of that. Our next question, a motor vehicle is brought to rest from a speed. So it has been moving already with an initial velocity of 15 meters per second. You can see the car moving, and then it was brought to rest. Our final velocity will equal 0 meters per second. Then the time it took for the car to be brought to rest was 20 seconds. So you can see that our T is equal to 20 seconds. We are asked to calculate the retardation, which is the negative of acceleration. Take note of that. So we have to apply the formula of acceleration, after which the negative form of our answer becomes the retardation. Take note of that. So using the first equation of motion, v is equal to u plus at, we have 0 is equal to 15 plus a into 20. So that 0 minus 15 is equal to 20a by collecting of like terms. So that negative 15 divided by 20 is equal to negative a when you divide through by 20, so that you make acceleration the subject of formula. And then negative acceleration becomes retardation. So that you have negative 0.75 is equal to negative a, because we are dealing with retardation. Hence, your a is equal to 0.75 meters per second squared. Take note of that. Connect to our social media handles at Physics Bible, the TRiUNE Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.